Today we are going to Science Form 2, Stability. Okay, as we prepare ourselves for this chapter, we need to look at the field lesson overview, center of gravity and the determination of center of gravity for irregular objects. Stability of various objects are affected by many factors, as we will discover it later. To study how the center of gravity influences the stability of an object, to study how the base area and weight influence the stability of an object, the importance of stability in animals and objects, applications of stability in daily lives. As we begin, we want to define a few things. The first thing is point of equilibrium. What is point of equilibrium? An object can be considered to be in equilibrium when it is stationary or at rest. Means it is not moving at all. For example, if you could balance your ruler like this, you should be able to balance it without it dropping. As you can see from here, the one with the finger at the middle. Okay. What if you put your finger on the other side? If you place your finger at the middle of the ruler, it can be balanced and not falling to the ground. Yes, that's for diagram A. If your finger is placed in a non-middle position, it will fall. Okay, this is quite obvious. You can try it yourself. So now let's define the center of gravity. What is the center of gravity? The center of gravity of an object is the point at which the weight of the object seems to act. The keyword is the weight of the object seems to act on that single point. Okay, if you have a boat, you're carrying a boat in front of you, and then you can visualize that the middle point of the whole object is the center of gravity. Okay, you have a cube box. The middle of the whole cube box is the center of gravity. So we encounter different types of objects in our life, and we need to find the point of equilibrium. Most of the regular objects like this, they actually can help us to find the point of equilibrium or center of gravity quite easily, simply by drawing. Okay, because they are regular objects, so we draw this and that. The intersection of two lines will give you the point of equilibrium, or you can call it center of gravity. Even for this one, hexagon, the center is here. Square, center is here. Equilateral triangle, center is here. But what if you have this almost the same also? This one is regular object. Again, as you place a pencil here, you can hold it, or you place a pencil here, you can hold it, and the center of gravity can be found quite easily. For regular polygons or objects, the point of equilibrium lies at the intersection of the diagonals. Diagonals means this line. This line is called a diagonal. This is another diagonal. So two diagonal intersect to get the intersection, and you can find the center of gravity. So the center of gravity of a regular object is determined by measurement. Okay, so how about irregular objects? Okay, the person is scratching his head, wondering, but how about the following objects? The following objects doesn't have a regular shape, so they found out that the center of gravity is outside the L plate. Center of gravity is inside the hollow hole, and center of gravity of this bench, seems like a bench to me, is actually under the bench. The object shown above has center of gravity outside the body. So how do we find out the center of gravity of the object, irregular objects, but how is it outside? How do we know that it is outside? So we carry out this activity. As we carry out this activity, you see there's a retort stand, and there's a support here. So this irregular shaped cardboard is poked at different places, P, Q, and S. No, this R, Q, and S. So at Q, they poke through and then they tie a plumb line. A plumb line is a line that is attached with a pendulum bob. Okay, is a BOB, and so it's tied here. So it's along this line. When you use pencil to sketch this line, okay, and then when you change position to P, you flip over clockwise. P, you get the same thing. You sketch the line, and then as you flip over anti-clockwise, you get the same line sketch with your pencil, and this is the result of your sketching. Okay, just now it was sketching, then you can use a ruler to complete the lines, and you get the center of gravity for these irregular objects. Maybe for L plate or the hollow centered circle or the bench is found this way. Okay, so the vertical lines from each suspension point are drawn. Okay, you use a pencil to sketch it. The center of gravity is the point of intersection. Intersection means they meet around here. They meet each other at the same point. The center of gravity of irregular shaped objects may not be located at the center of middle object, like the regular shaped objects. It's not like the regular shaped ones. It may not be in the middle. Some still yes, still in the middle. Okay, so this is how we do it. We want to determine the center of gravity of irregular objects. So hang the irregular piece of cardboard freely from a point. That's the first step. Okay, from one point. Hang a plumb line from the same point. So you hang here. Draw the plumb line. Use a pencil to sketch. Repeat the steps, but hang the cardboard from another point. A few points, maybe 3 or 4 points, to get intersection. But basically 2 lines is enough. Maybe you want to use third line to confirm it. So the 2 plumb lines cross each other. That's the observation. And the calculation is the point where the 2 plumb lines cut is the center of gravity of the cardboard. Explanation. The center of gravity of a freely suspended object lies directly below its point of suspension. Okay, so these are just below the point of suspension. Below the point of suspension is the center of gravity somewhere below the point of suspension.